All right, everybody, this is our last Unit 6 video, and we are going to talk about some graphs. So we have two types of roots that we're going to be looking at the graphs for here. We're going to focus on just square roots and cube roots, okay, and they look very different. So the square root parent function would just be f of x equals the square root of x. And we know we can't square root negative numbers. If we do, we get imaginary numbers, but we're not going to be able to graph those on a normal coordinate plane. So the first number, the first x value I can actually square root is 0. If I square root an x value of 0, I'm going to get 0. So that would give me the point 0, 0. If I square root 1, I get 1. The next x value I could square root would be 4. So if I have an x value of 4, I'm going to get a y value of 2. And the next x value I can square root would be 9. Square root of 9 is 3. So you can kind of see how I'm piecing my graph together here. Now, if I were to type this into my calculator, graph it, look at the table, you're going to notice that our graph doesn't have arrows on each side. This is weird for us. Okay, we haven't really ever seen a graph that does this. Typically, there are arrows on both sides, but the square root function doesn't because we can't square root those negative numbers. Now, it might be shifted left or right some. It's not always going to start right here at the origin, but the parent function will. The only thing that will move this, what we call end point, are horizontal or vertical translations, which we'll talk about. So the end point for the parent function is going to be located at 0, 0. Because of that, the domain is strictly, all of the x values greater than or equal to 0. And the range would be all y values greater than or equal to 0. So kind of a weird one. Okay, let's look at the cube root parent function, which is just the cube root of x. And because we can cube root negative numbers, it's not going to have an end point like the square root function does. Okay, we're going to have arrows on both sides. So let's just start in the center. Okay, if I cube root 0, I get 0. Okay, now I want you to think of your perfect cubes. 1 is a perfect cube, so if I cube root it, I get 1. My next perfect cube is 8. So if I cube root 8, I get 2. So the right half of my graph looks like this, kind of like a square root. But the difference is I can also cube root negatives. If I cube root negative 1, I get negative 1. If I cube root negative 8, I get negative 2. So the left half of the graph looks like this. So we've got arrows on both sides. Now the turning point, okay, it's not so much a turning point as it is just kind of the point in the middle of that wave is going to be located at 0, 0 here. We have a domain of all real numbers, and we have a range of all real numbers because our arrows are going to the left and right, up and down forever. So let's talk about transformations. Okay, this is pretty much the same form that we saw for absolute value and quadratic functions. Okay, the h that you see in here corresponds to left and right. Okay, horizontal translations. So h is your horizontal shift. Okay, just as normal, if it's x plus some number, it's going to go left. If it's x minus some number, it's going to go right. Backward, okay, and then k corresponds to the vertical translations. Okay, if it's plus some number, it goes up. If it's minus some number, it goes down. That end point is going to be found just by really combining your h and k values. Okay, however much you moved it up, down, right, left, that's going to move your end point, right? So if I, let's say, shift my square root function left 2, that means my endpoint, which starts at the origin, is also going to shift left 2. Now let's take a look at A here. A can do a couple things. Okay, if A is negative, we know that that makes it reflect across the x-axis. And then if A is greater than 1, if we take the absolute value of A and it's greater than 1, we call that a vertical stretch. And if A is between 0 and 1, after we take the square root, we call it a vertical compression. So we've seen all of these transformations throughout the year. We can extend it to the square roots. So let's look at some transformations here. So we're going to do a couple things. We're going to describe the transformations compared to the parent function, and then I also want to state where the end point would be. So here, the -7 means that we are going right 7. The +2 means we're going up 2. So the end point would be located at 7, 2. Okay, for this cube root that we have here, the 4 would be a vertical stretch. And then this -1 is outside of the radical, so that means it is down 1. Okay, so my endpoint here, which typically is at the origin, is shifted just down 1. It didn't go left or right, so the x value is still 0. The y value is now at -1. Oh. All right, so the last thing I want to do here is actually look at graphing one of these. Okay, so let's start with finding our endpoint. That's always a good place to start. Here I can see it went right 1 and down 4. So my endpoint is going to be at 1, -4. Now, what I'm going to do from here is just type this function into my calculator, look at the table, really what we've always done for graphing, just to get the rest of the points that I'm going to plot. Once I get those points, I'm going to put them on my graph, connect them, and then we'll look at the information that we have. I think I went over too far. Okay. So here's my function. Now, because the endpoint was moved, that's going to affect my domain and range. The domain would be x values greater than or equal to 1. Okay, and then my range would be y values greater than or equal to -4. For the end behavior, it's going to look a little different. Okay, as x approaches infinity, so as we go along to the right side, that arrow is going up gradually, but it's going up, so f of x is approaching infinity. But when we look at the left side of this graph, as I approach the left side of my graph, I'm not approaching an x value of -infinity because my graph doesn't go that far. I'm approaching my endpoint, which has an x value of 1 and a y value of -4. So on the left side, we're not approaching infinities, we're approaching the endpoint, so you're just looking at the x and y value at your endpoint. Now, for the square root functions, we're not going to have increasing and decreasing intervals. It's just going to be one or the other. If we go from left to right on this graph, it is only ever going up. It is only ever increasing. So we don't have a decreasing interval. We're still using the x values to describe the increasing interval. So it starts increasing at an x value of 1, and it increases forever up into those x values of positive infinity. Now, I wanted to look at the graph of a square root because it's a little different with that endpoint. When you graph the cube roots, you're going to have the same approach. Type it in your calculator, get your points, and that's going to be much more similar to the other functions we've looked at this year because you've got the arrows on both sides. So let me know if you have any questions, and have a great rest of your day.